Think back to the last time you dined in at a 5-star Yelp reviewed restaurant. What was it that you ordered and why? Was it the exotic name of the dish that had you salivating on the menu, or was it simply just the list of ingredients that prompted you to declare, I know what I'm getting? For me, the ingredients on a menu are the best way to understand what to expect when I order. What about the ingredients needed for a finite element analysis? That is, after all, the fancy name of an engineering entree. But if you break it down, you'll find that it's really made up of familiar portions of elements that we already know. So let's keep it simple and order up one of my favorite menu items, a simple New York strip steak. We'll prepare it 2 ways, the home cookout or our static analysis, and the I am so full but I'll have another for dessert item, which will be our nonlinear approach. Again, similar ingredients, but with a little more finesse and control in the latter. Are you hungry yet? Let's take a look. The setup is pretty straightforward. The goal is to determine the reaction forces of this gasket to ensure a proper fit without overstressing the model and the metal inside of the support structure that has been overmolded into the gasket. A prescribed displacement will be set to account for the closure onto the gasket itself, with a simple fixture to hold it into place. Now it's time to go shopping for our steak, and the quality of the cut will set us up for how delicious this meal will be. The static analysis will just use a basic local grocery store chain cut of meat. This meat will represent the model and the material of our study. Nothing special, a few standard values like modulus of elasticity and a yield point to define what the behavior and the results of our study will look like. This modulus of elasticity value really determines the linear relationship between the deformation and the stresses that are induced during the loading of the study. They're good results as long as we work within that linear relationship of the material. So keep in mind, in a static analysis, you're limited to just that. Materials like rubbers, plastics, foams, and even some alloys that are outside of the linear curve require further definition than what's really allowed with us in a single material value that we find in the static analysis. Our store-bought steak is ready for the grill. In a static analysis, the simulation assumes a static load, or it's held in place in the final position from the load that we applied. This gives us good insight on how much the model will deflect and the stresses occurring at that position of the deflection. Static analysis gives users a bunch of options for creating these types of loads, but we really don't have any control on how the load is applied. And back to our steak, less control in the cooking process on our steak equates to more variability in the end results. Let's get our second steak ready. This time it's a locally sourced, grass-fed, and properly aged cut. Again, we will let this define our model and material, but for a nonlinear study. Nonlinear allows us to define the material behavior and how it responds during the loading and isn't constrained to just a linear trend like we saw before. Along with the better definition of the material, the load can also be defined as a curve, and this is an important part about getting precise results. Think of this as a better temperature control when searing and finishing the steak during the cook. A grill is good, but searing on a hot cast iron pan followed by a low temperature oven is a finish for the pros. The initial seasoning is the same for both steaks. A good rub of salt and a pinch of pepper. This represents the contact in our analysis, or how the parts in the assembly are going to interact with each other during that loading. The static analysis allows for this interaction, but it won't update any of those contacts and change the stiffness of the model if that were to happen in the study. In other words, we have one attempt to properly season the steak. If you need to add anything during the cook, well, you're out of luck. With the nonlinear analysis, we can baste the steak with butter and garlic, add additional rosemary and salt as you need. Nonlinear allows for contacts to update as the model is running. Again, this is giving us better control and precision along with accuracy in our final results. Okay, both steaks are cooked and they're ready to be cut into. I'm really excited to compare the results between the two. Which one do you think came out a little better? The static analysis results look good. Of course, most of my steaks do. But when we cut in, we start to see results that reflect a backyard barbecue. It's still pretty tasty and it's still juicy, but it's not world class. My goal was to see the response of the gasket during the loading, but I only see the peak response. And because the material is rubber, along with the changing context, I'm really not confident we have the optional controls needed in this study to determine the results I was looking for. Looking at our second analysis, the nonlinear run, cutting into the results shows much better replication of the real-world conditions. And comparing to the static study, we see a 2x difference in the results. Are you hungry yet? An everyday steak can be quick and easy. Just head down to the local grocery store, grab the daily special, and toss it on the grill. To make that steak something worth remembering, well, it doesn't take a lot more. Better selection of meat, using just the right amount of seasoning, and of course, perfect control over the temperature through the cooking process. Is a world-class steak going to be for every single meal? I wish, but I wouldn't expect so. So knowing that it's just a few more ingredients and a little more attention to detail can really go a long way. Just remember, there's an opportunity to cook them both, just with the simulation. Static analysis gives limitless insight into design, but understanding when to go the extra step with these ingredients and the control really will ensure a satisfied customer every time. Do you want to learn more about SOLIDWORKS simulation? Give your local reseller a call today. They've got a lot of information on training and also available packages from SOLIDWORKS.